So this lecture will be a little shorter. I'm going to get to the point. There's lots of pictures that you can go look at on the joints visual aids slides. I do believe those are posted in your book, in the atlas. So make sure you take a look at a lot of these things that we'll be going over that I'm not including pictures of, especially the different movements and some of those. I'm not going to spend a lot of time talking about them, but you definitely need to know the types of joints, the types of movements, etc. So here we're talking about joints which are going to give the skeleton mobility and hold it together, and they may sort of also provide some protection, mostly from injury based on stability and movements that they can and cannot support. So joints are what are known as articulations, which are is a meeting point between two or more bones, and in most cases it allows movement. But they also, while they might provide some protection, they are also the weakest part of our skeleton. Kind of tough to kind of soak that in. There are two ways to classify joints. The first is a functional classification, so by the amount of movement they allow. We have synarthroses, which are immovable. You'll primarily find those in your axial skeleton. We have amphiarthroses, which are slightly movable, and we have diarthroses, which are our primary type of joints, and they are freely movable. Our second way to classify is by the material that binds the bones together and whether or not there's a joint cavity. So we're going to start with a brief look at the three categories of articulations, and then we'll go into a little bit more information about each of these three categories. So first up, we have our fibrous joints. They are exactly what they say they are, fibrous connective tissue. There is no joint cavity. They are only rigid to slightly movable, so you're talking primarily synarthrosis. So there's collagen fibers, dense irregular connective tissue, and we'll talk about the three types of these on the next slide. We have our cartilaginous joints, which are held together by cartilage. Again, no joint cavity. They allow some limited twisting and compression. You typically see your synarthroses and your amphiarthroses here. And again, we'll talk about these on a later slide. And finally, our synovial joints, our most common type of joint, our diarthroses, held together by ligaments. They have this wonderful fluid-filled joint cavity, which you'll see in more detail as it comes. The bones are lined by articular cartilage, which is hyaline, and they're going to allow for a wide range of precise, smooth movement. Most of the joints in the human body are, again, this type, synovial. First up, our fibrous joints. We have three types. You can see those types named here. We have our sutures, our syndesmoses, and our gomphoses. Your sutures are like the seams of the skull. They are held by a thin layer of dense, irregular connective tissue. Then you have your syndesmoses, which they are held by collagenous fibers, interosseous ligaments. Really, the exclusive connection there is by ligament. You see these in, for example, your radio-ulnar joint. Yes, there's a joint between the radius and the ulna. You'll probably get to see that again later. But also the tibiofibular joint, where the tibia and the fibula meet. So keeping an eye on those. And then finally our gomphoses, which is kind of the peg and socket idea, where your tooth is attached into the socket by the periodontal ligament. So it's the tooth in the bony socket via that periodontal ligament. And that's your gomphoses. And that's really the example of that one. This is just going to let you take a look at the comparison of the 3 fibrous joints together. So while they have similarities because they're classified together, you can see that they are different. And this will just give you a quick look at that. So take some time to look this over. Next up, we have our cartilaginous joints. Remember, we were talking about immovable or slightly movable as far as joints go in these categories. We have 2. We have our symphyses, which are bones separated by a pad of fibrocartilage. Best example of this is the pubic symphysis. So it's a plate of just fibrocartilage at the you have places like the first rib and manubrium between the pubic bones and some vertebral discs. And then your synchondroses are your plates of hyaline cartilage. These are typically synarthroses. These are immovable, things like your epiphyseal plate. And we have, that would be an example of like a temporary joint. Your costal cartilage would be more of a permanent joint. So those are the two when it says temporary versus permanent. Temporary being your epiphyseal plates, that's hyaline. Temporary, it's not there forever. And then your permanent are your costal cartilages, so they're at the ribs. And again, look at a comparison of those 2 cartilaginous joints for your review. Get a quick look at where they're located and kind of some structural similarities, even though they're in different places, right? And again, hyaline versus fibrocartilage, and just understand the difference. And onward and forward into our most common, our primary category of joints, which are our synovial joints. These are going to allow for wide ranges of motion with strength and stability, and they are typically connected at 2 or more points, and we'll talk about that again a little bit. But your range of motion and stability are determined by these 3 things you see listed here. So bone structure, meaning the shape of the articular surfaces, and the shape is going to determine the movement. And you'll see this when we get into the different classifications of actual synovial joints. The strength of the ligaments and the capsule, more ligaments, more strength. So if they're supported by 1 versus 2 versus 3 versus more, right, you're going to typically see more strength related to that synovial joint. Interesting, right? Stretched ligaments stay stretched to about 6% of length. And then after that, they could snap. So we're paying attention to the stability of our joints and protecting those things. That's where your PT comes in and pays attention to joint stability and some of those rehabilitation type things. And then finally, the size, the arrangement, and the action of the muscles. So tendons are going to cross the joint to stabilize them. Muscle tone is the low-level constant contraction and relaxed muscle, keeping them ready to react. That's essential. And then they're always going to be connected at 2 or more points, right? We have an origin, which is the immovable or less movable bone, and the insertion, which is at the movable bone. So movement occurs with muscle contraction across the joint, insertion toward origin. I'm going to say that again. Your origin is your immovable or less movable bone. The insertion is your movable bone. So movement is going to occur with muscle contraction across the joint, with the insertion moving toward the origin. I'm going to let you just sit with that for a moment. Replay it as you need to. We have 6 types of synovial joints. It is essential. There are lots of questions relating to all 6 of these, both on the quiz and on lecture test 2. So there are bunches of questions relating to this one slide. I would suggest you go look at a lot of the pictures. I didn't include the pictures. You can look at those I've given you examples though, so hopefully that will be helpful. So we have our plane or our gliding joint, which is where we have two flat surfaces contacting each other. Our examples here are between the intercarpals, between the intertarsals. It's considered non-axial, and you can look that up. Our hinge is a uniaxial, working with just flexion and extension. So you can think of the work of the knee and the elbow, that's the hinge joint. Pivot, also uniaxial, dealing with rotation. It is the proximal radius and ulna would be an example of that. So your radial ulnar meeting point. Condyloid is biaxial. Very important to understand convex and concave. So if you need to look up which one looks like the cup and which one looks kind of more like a mirror shape, I would suggest you do that. So the condyloid is convex bone articulating with concave bone in more than one direction. So you have your metacarpals, your phalangeal, that's what you find here. Saddle, you have both surfaces are both convex and concave on the same bone. So you're thinking about your thumb. Biaxial, you get a little bit more motion out of your thumb than you do out of your fingers. And then our big one that we tend to pay the most attention to, other than hinge, so injuries to hinge, injuries to ball and socket, very common. Old age kills ball and socket joints really nicely. Ball and socket is your multi-axial. You have the head in a socket providing a multitude of motions, ranges of motion here. So flexion, extension, abduction, adduction, and rotation. And you will see all those motions later and be able to kind of tie them together. But here you're looking at the shoulder and the hip. And again, there's like 4 or 5 questions or parts of questions relating to this slide. So make sure you look at some pictures, look at this language, look at these words, and make sure that you're understanding the difference between these different types of joints and the types of motions. You're going to connect with some later notes on the type of physiological range of motion that we're talking about. So we have the picture of a basic synovial joint here, and the joint cavity contains a small amount of our synovial fluid, which I'll define in just a moment. It's potential space. So as we go through these, you have an articular joint capsule, which is fibroelastic tissue that envelops the joint. It's made up of 2 layers, a fibrous layer, which is your tough, external, dense, irregular connective tissue, and then the synovial membrane itself, which is the inner lining of the capsule. Its primary job is to secrete synovial fluid, made up of loose connective tissue, and it's going to cover all of the internal joint surfaces that are not hyaline. So its job to secrete synovial fluid, the synovial fluid is just for lubricating the joints, reducing friction. It's going to nourish the articular cartilage, and it's what actually occupies those potential free spaces. Articular cartilage is going to line those articular surfaces made of hyaline cartilage. It's going to absorb the compression, keep the ends from being crushed. And then you have your bursa, which is going to be a synovial fluid-filled pouch. It's going to cushion between the bone and tendon. Anywhere you have a ligament, muscle, skin, tendon, or bones rubbing together, you could have a bursa. Your ligaments, bone to bone, tendons, muscle to bone. So here's the diagram. Let's just walk through these again. All right, so you can see there's a whole bunch of words on the one side of the screen, but the joint cavity, remember, is this potential space that's going to contain some synovial fluid. So that's the home for the synovial fluid. Okay, your articular joint capsule is made up of the fibrous layer, that dense irregular connective tissue, and then your synovial membrane, loose connective tissue. And that synovial membrane is going to secrete that synovial fluid. Your articular cartilage is made of hyaline. Again, it's here to line those articular surfaces to keep them from being crushed. And you can see that we have an external ligament connecting bone to bone there. Not pictured, you don't have a bursa or a tendon in this particular picture. Over the course of the next 4 slides, you're going to get to take a look at the hip, the knee, the shoulder, and the elbow. Kind of work on getting to know, well, the names of the bones would be really good as we are studying all the system, getting ready for our lab test 2, which is all skeletal, but also identifying the synovial joint structure, what items are present in the 4 pictures, and then thinking about the hip and shoulder versus the knee and elbow and the hinge versus ball and socket. I'm not going to talk anymore on any of those other slides. They're really here for you as kind of general understanding of 4, that I consider 4 of our kind of major joints that we tend to do some really good work with as far as when we're active and or aging. So here we are, really this is the end of this lecture. The rest of the slides are all pictures that you can look at depicting the different types of motion to help you kind of understand what's going on. But we have, primarily we're going to talk about physiological movement, which is a joint motion that you can reproduce. We also have things that are accessory movements. Those are joint motions that you cannot reproduce, but they're necessary to complete the physiological movement. I'm not going to necessarily spend any time kind of any more than that, because really what we're focused on are types of physiological movements here in this list. We have things that are considered angular movements, and these are ones that specifically are going to increase or decrease the angle between 2 bones. I've labeled those for you. There are primary types of movements, so flexion and extension, abduction, adduction, and circumduction. One more time, flexion, extension, abduction, and adduction, and circumduction. As far as the definitions, I'm going to run through them for you, but really focus on keeping this simple and finding ways to define how it makes sense to you. Flexion, you're talking about decreasing the angle, bringing bones closer together. Again, decreasing the angle, bringing bones closer. A lot of times you'll see bending along the sagittal plane with this. Extension is going to be your opposition to flexion. So we're going to increase the angle, straightening a flexed joint. Sometimes we get hyperextension, which is beyond the standard straightening. The pictures will show you examples of that. That'll be really nice to look at. Okay, so extension is our opposing work to flexion. We are increasing the angle. Next, we have our AB and adductions. So ABD, your abduction, think of it exactly like what it means to be abducted. It's to take away. So it's movement of a limb away from the midline. Okay, movement away from the midline. So if you stand up in anatomical neutral, right, and then you move your arm away from your body, lateral raise. Abduction, it's being abducted away from you. When you take that arm and you put it back to its side, AD, you're adding it back on. So that is the movement of the limb toward the midline, adduction. So AB, abduction, take away, adduction, adduction, move toward or add on. Okay, and that has to do with your midline, so straight down the center, mid-sagittal. With rotation, we turn a bone around a long axis. Okay? Turning of a bone around the long axis. Think of it as saying no. Right, you get between the first 2 cervical vertebrae, atlas and axis, which allow you to say both yes and no. Okay, rotation is going to be that movement between the first 2 cervical vertebrae. You just say no, turn your head from side to side. Pronation and supination are specific to the movement of the radius around the ulna. So if you're standing in anatomical neutral or laying on your back, palms facing the ceiling, Shavasana, corpse pose, if you were to turn and put your palms down toward the ground or toward your back side, that is pronation. Supination is automatic when you're in anatomical neutral or when you're in corpse pose in your yoga class and you're laying on your back with your palms up, playing dead. That is automatic for supination. You are already supinated in that if you turn those palms to face down or face towards your backside, right, that's pronation. So make sure you understand the difference. Palms up, anatomical neutral, supination, rotating so that the palms face back, that's pronation, or turning the palm down. Circumduction, think of it as moving your arm, doing arm circles is the best way to do circumduction. The distal end of your limb moves in a circle while the point is stationary. So that hand is moving and the shoulder is stationary, kind of, right? So you get all four, flexion, extension, ab and adduction in succession as you kind of go around, right? So think about it, if you start in anatomical neutral, the arm is abducted and the shoulder joint is, technically you're moving those bones closer, so you get shoulder flexion, then you get adduction and shoulder extension, right? And it continues in your circle. I hope I said that right. I'm very tired today, so I apologize if I got it backwards. Inversion and eversion have to do with the direction that the sole of your foot points. So if you are standing in anatomical neutral and you roll to the outside of your foot, meaning that the bottom of your foot points toward the midline or toward your other foot, okay, let's think about that. You're standing in anatomical neutral, you roll to the pinky side of your foot, so now the bottom of your foot is facing your other foot. That is inversion, so the sole turns medially. Eversion, the sole turns laterally. So in eversion, you're standing there, you roll onto the big toe side of your foot, point the bottom of your foot out away from you laterally, that's your eversion. Inversion sprains are much more common. That's every time you step off a curb and roll your ankle, you're typically getting an inversion sprain, even if it's minor. That burning for a moment, that's a minor inversion. Your ankle's angry with you. And you'll see a picture, so that'll help too. And then you have your protraction and retraction. That is essentially, retraction is bringing your jaw in line, so just nice, quiet, sitting there with your mouth closed, jaw where it belongs. When you jut out your jaw, stick your jaw forward, which kind of goes hand in hand with pouting a little bit, but if you make that jaw pop forward, that is protraction. And then we have elevation and depression, which has to do with opening and closing of the mouth. Your depression is moving a part inferiorly, so dropping the mouth open. Elevation is lifting the body part superiorly, close your mouth. Shrug your shoulders, the shrug, elevation. The relaxation of that shrug, depression. Okay, so depression is moving the part inferiorly. Elevation is lifting the body part superiorly. And our last special one down at the bottom has to do with pointing and flexing your toes. Plantar flexion, pointing your toes, good for divers, good for swimmers, good for dancers, anything that requires a really lovely toe point. Dorsiflexion is when you draw the top of your foot towards your shin, flat foot. Okay, we spend more time in more dorsiflexion type activity walking than we do plantar flexion, unless you are a toe walker. And then you would be walking in plantar flexion. The only thing I can say about toe walking is that I'm kind of jealous of the calves they develop. Quite beautiful, actually. They get nice, wonderful pointed toes and some great calf muscles from toe walking. I wish I could do it. Anyway, all you'll find on these next few slides here are the pictures of the movements, and I've included those here. I wasn't sure where they were, so I wanted to make sure you had these. Like I said, there's a lot of pictures, so roll through those at your leisure. And let me know if you have any questions. Remember, you can always send me an email. We can always set up time to chat. Check back in anytime you need to. I'm here.